prove that the limit x going to 3, x squared minus 4x equals negative 3 using the precise definition of a limit, or the epsilon delta definition. So for this problem, we need to know a couple of formulas or definitions which state the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. And we kind of have the format right below, limit f of x equals L, and then x going to a. So as you can see right here, the x squared minus 4x is the f of x, or the function, and that is equal to L. And the limit x going to 3 is going to equal a. As you can see here, that question follows the same pattern as the formula. Another way that you can kind of rephrase the question is by saying, show that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon, as shown right here. This is kind of combining both formulas that we gave at the beginning, so it makes more sense like that, I think. So the next step of this problem would be to basically put the original equation into that form of absolute value of f of x minus L is less than epsilon. So that is precisely what we do right here. We move the negative 3 to the left side of the equation, which gives you x squared minus 4x plus 3. Absolute value of all of that is less than epsilon. So after successfully converting into that form, you basically just want to factor out the inequality now. So that leaves you with x minus 3 times x minus 1, and that's going to be less than epsilon. So as you can see here, well, I forgot to write epsilon here, but side note that the expression or the inequality on top is x minus a is less than delta, and then a is equal to 3. As you can see here, x minus 3, a is equal to 3, so we can kind of convert it into that form already by dividing the left side by x minus 1 as well as the right side and isolating the x minus 3. So now that we have it in that form, x minus 3 is less than epsilon over x minus 1, we can say that epsilon over x minus 1 is equal to delta. Now, to verify this, we can set up the other equation, which is the absolute value of x minus a is less than delta. Now, since we established that delta is equal to epsilon over x minus 1, we can say that the absolute value of x minus 3, remember that a is equal to 3, so the absolute value of x minus 3 is less than epsilon over x minus 1. And this is kind of doing the reverse process of what we just did in the previous steps. So we want to isolate that epsilon. So to do so, we multiply by x minus 1 on both sides to cancel out the denominator on the right side. And that's going to leave us with absolute value of x minus 1 times x minus 3 is less than epsilon, as shown here. Now, we can FOIL x minus 1 and x minus 3. And that's going to leave us with the absolute value of x squared minus 3x minus x plus 3. Absolute value, of course, can't forget that, is less than epsilon. Now combining like terms, we get x squared minus, not 3x, minus 4x plus 3. Again, don't forget the absolute value is less than epsilon. And as you can see here, this equation matches up with our original equation of f of x minus L is less than epsilon, thus proving that absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon.